The nice thing about it is that they tell me that. And that's maybe insightful on what we really have here, okay? Because looking at it doesn't look like it's a quotient, right? It doesn't look like division. But when we have negative exponents, say I had x to the negative first, okay? Don't we rewrite that with that variable in a denominator, change the exponent to a positive 1, and then whatever's left up top, and in this case 1 would be left up top, and x to the negative 1 is the same thing as 1 over x. You guys remember that? Okay. If it was x to the negative second power, I'd have 1 over x squared. Okay? So it's the same concept here. And then those, initially, maybe we don't realize that this left-hand side is showing me a fraction until we write it this way, or showing me a quotient until we write it this way. So that's the same thing going on here. Okay? I want to rewrite this thing so that 7 minus 8i has a positive exponent of 1. Okay? If you want to put that 1 in there, you can. It's not a big deal. But now what would be left in the numerator? Yeah, just a 1. Okay? So now you have a complex number divided by a complex number. Remember, I can always do this. It's kind of silly here to do that. But plus 0i is still a complex number, right? So the whole thing, the whole procedure that we go through is that we have a complex number divided by a complex number. We want to make that into just one complex number instead of having two. Okay? So the division allows us to do that. But we're really not going to divide. We're going to do what? Multiply. We're multiply by, careful, conjugate. We multiply by the conjugate of the denominator. Always has to be of the denominator. Okay? Because the idea, the goal, is to make the denominator a pure, real number. Okay? And the only way you can do that is through conjugates. Okay? In the past, I would get people on tests to multiply by the conjugate that's on top. Okay? So if I had like a 2 plus 3i up top, they would multiply the top and the bottom by 2 minus 3i. Well, that keeps a complex number in your denominator, and just by general rules, we don't like complex numbers in denominators. Okay, so that's why we multiply by. That's why we choose the denominator to use its conjugate. I also see people. Well, let me ask this question first before we do anything. What do we really multiply by there? 1. Okay, I see a lot of people want to multiply the top by its conjugate and the bottom by its conjugate. Well, if you do that, you're no longer multiplying by 1, and you change the value of this fraction. Does that make sense? So we want to make sure that we don't do that. All right. But now when I multiply those things, top, pretty easy, is 7 plus 8i, right? And the bottom now, 7 times 7 is 49. And then 8 times 8 is 64. It'll be negative 64. And we got our I squared, right? The I squared becomes a negative 1, which is going to change the sign of my 64. So now I got 7 plus 8i all over 49 plus 64 gives me, what, 3, 1, 113, is that right? Okay. Now, I think if you type it in that way, WebAssignment's probably going to throw a fit about that, okay? Because it's really not in this form, okay? We're going to take 7. What this really says is we have 7 divided by 113, and we have 8 divided by 113, and then our I, okay? And that I can actually show up on the outside like we have it, okay? Like I have it, or it can show up in the numerator. You just can't put it in the denominator. Okay, so that's what we're looking for: 7 over 113 plus 8 over 113.9. And like I said, I think that's just kind of an intricacy with WebAssign and how they're asking it. On your test or quiz, we're going to do those by hand. So if you write it, I'll just say evaluate. I won't give you all these instructions. If you just come up with that, that is 100% fine with me. Okay, you don't have to go that extra step. Is that problem doable now? Okay. Another one that I saw struggles with was the next one, 21. Remember when we get quotients, and our goal is to evaluate or simplify, and there's operations happening in the numerator, there's operations happening in the denominator. We want to think about those operations in the numerator individually by themselves. Okay? Condense those and change those as much as possible. Do the same thing in the denominator. Okay? So reevaluate both the numerator and the denominator, and then once we've condensed them, then do that overall division between the numerator and denominator. Does that make sense? So what I'm saying here is we want to do this product first. Make that simpler. Okay? So in doing so, we're just going to FOIL. So 9 times 4 gives me my 36. 9 times negative I is negative 9I. 3I times 4 is positive 12I. And then we get negative 3I squared. That numerator then is going to change to, that'll be a plus 3, so I'll have 39 plus 3I, correct? So that's what that yellow stuff turns into. So I'm going to rewrite the problem then, because this makes it so much easier now. I now have 39 plus 3I over 3 plus I. And that problem is a little bit more condensed than what we started with. Okay? We've gotten rid of that product. Now, what do I do here then? Multiply by the conjugate. So we're going to get 3 minus I there, 3 minus I there. And up top, that's going to 39 times 3. So 137. Huh? 117. Okay. 39 times negative I is negative 39I. 3I times 3 is 9I. And then we have negative 3I squared, right? On the bottom, it's going to have 9 minus I squared. Start combining like terms. I squareds become negative 1s. The only thing here, remember, it's 9 minus a negative 1 I squared. So when I change that I squared, it's going to become positive 1 there, right? I do get a lot of people just to cancel it out and leave with a 9. It does end up turning into a 1. So 10 on the bottom. Up top, I'm going to have 117 plus 3, 120. And then minus 30I. All of them have a factor of 10 in them, right? So I'm going to find my final answer as 12 minus 3I. Hopefully you realize once you do one step, you know, this might be like question 5 or 6. Okay, you develop this, which is just like questions like 8 and 9. Does that kind of make sense to everybody? And that's what a lot of the problems throughout the course you're going to do. The further you get into an assignment, they're starting to wrap up 2 or 3 previous questions inside one question. Okay, on a test or a quiz, I think that would be a good question for me to ask, because that tells me 2 things inside one question. It's going to speed things up for you, I think. It's going to tell me, is student A proficient at multiplying complex numbers, and are they proficient at dividing complex numbers by just looking at one solution? Okay. Another one, and this is going to be a very important part of this course, is a question like 22 and how our solutions show up here. Okay, we think about the numbers. We just want factor. That's all they say here. Factor, and I think it tells you to write your terms or your answers in A plus BI form, which should be then insightful. This thing doesn't factor by looking at a product and a sum. Okay, the factors of 26 are 1 and 26, 2 and 13, right? Okay, none of those add up to give me 10 as a group. Okay. So it doesn't factor real nice. So if that doesn't factor that way, what is my last resort for factoring? Quadratic equation. Quadratic formula. I always mess that up. It's quadratic formula. Opposite of b, plus or minus, b squared, minus 4, a, and c. All over 2a. Just 2 in this case. So we have negative 10, plus or minus, okay? This is going to be 100 minus what, 104? Okay? So 100 minus 104 just gives me negative 4 and then the radical, right? All over 2. And here's the logic here that I want you guys to make sure we understand. If you algebraically compute this and you get a negative radicand, and remember that's the discriminant, right? That's what we call that for the quadratic equation. If you find the discriminant was negative, then there was no easier way to factor this. The product and sum technique didn't work, wouldn't have worked. The factor by grouping or the A times C method would not have worked. This is the only thing that would have worked for us. If this comes out to, if it was like a positive 4 and you get down to a real number as an answer, a really nice, maybe a fraction or a really nice integer, that tells you that factor by grouping or the product and sum technique would have worked. Okay, and that's just something that I think is useful for a lot of people later on, is to realize that answers can provide you insight on alternate routes. Okay. Obviously, this answer does not allow alternate routes. So we get negative 10 plus or minus square root of 4 is 2, right? And then negative has to come out as an I. So 2i, and then divide by 2. So what's negative 10 divided by 2? Negative 5 plus or minus 2i divided by 2 is just I, right? So my two solutions for x, negative 5 plus I, and negative 5 minus I. What do you notice about those two solutions? They're what to one another? Conjugates, okay? When you have complex solutions to any polynomial equation, they are going to show up as conjugates. So if I go through work and I know that negative 5 plus I showed up, automatically I know negative 5 minus I will be there as well. No, I like to like a shortcut technique, like the product. No, that's this. You could do stuff like that, but I don't know that's going to be like the safest, like most convenient route every time. I don't know another one. Yeah, and that's the thing. They're because I don't know. I'm not saying that there isn't another way, but when we see patterns like that, that's a lot of times why we have like a product and sum technique, is because it was a pattern that we recognize over and over again. I'm not sure if there's a way. I'll research and see, but I'm not. I don't think there will be. But I'll look. No. And the quadratic formula becomes something we're going to factor all year, and that's or at least up to Christmas. And we'll get to trig. We'll do some factoring too, I guess. But that's going to be kind of a very important step with a lot of the things that we do in this course. If we think about this, you guys know that this is a parabola, right? Okay. The fact that I get those answers down there, -5 plus I, -5 minus I, what does that tell me about my parabola? Yeah, it has no real roots. It has no real x-intercepts. Okay? It doesn't cross the x-axis. Those are all similar ways of saying the same thing. So we have a parabola now, and I don't know what it looks like. I got a good idea now, but I know that my parabola is going to concave up, okay, because it's a positive 1x squared here. But my parabola is going to be, something like any one of those parabolas. Does that make sense? It's not, I know for certain it's not going to do that. It's not going to come down and exist at any point either on the x-axis or below the x-axis because of those complex solutions. Okay? And if you graphed it, we can graph it, I guess, real quick. If I go x squared plus 10x plus 26, we see then that it does mimic that idea. Okay, and that's what the course is about early on, is can we look at x squared plus 10x plus 26 and have an idea of what that graph looks like after doing a little bit of math. Okay? And hopefully we get to a point where we can just look at x squared plus 10x plus 26 and say, oh, well, that doesn't factor any convenient real nice ways. I'm probably going to get some ugly looking x-intercepts or no x-intercepts at all. Those are the questions that I seen people having questions about this morning. I had a couple emails about them. Is there anything else that you guys want to talk about?